Hi, welcome everyone. In this video, we are going to continue our discussion of chapter one of our textbook, which really is just introducing us to some of the core ideas regarding arguments and the logical structure of arguments and learning how to identify arguments. So just to review a little bit some of the material from the previous video, recall that an argument is sort of the main ingredient here um, of logic. And if I can just get out of the way here, an argument consists of different component parts. We are working with statements, which are just simple sentences, and then we are working with premises and conclusions, right? And so an argument is not just any description or fact about the world. It actually has a kind of logical form. And the idea behind an argument ultimately is to persuade us of a given position, right? And we encounter arguments in many different areas of life. We encounter them in the media, we encounter them in just conversations with our friends, with family, but also philosophy in logic becomes particularly keen on trying to explore what makes for a particularly effective and powerful argument. So just to move along here, recall that arguments use statements, and statements are sentences that have a truth value. We're going to talk a little bit more today about truth value and what that means, but to have a truth value means that the statement could be true or it could be false, right? In other words, the sentence is attempting to describe something in the world. It is meant to represent something in the world. And that statement is either an accurate representation of the world or it is a misleading or false misrepresentation. So a simple sentence like the cat is on the mat uh, could either be true or it could be false, depending on whether or not there is an actual cat sitting on the mat in the room, let's say. Right, so that might sound like an obvious property of statements, but actually it's going to raise very difficult and interesting questions regarding just how much you need to know about the accuracy or lack of accuracy of statements in order to buy in to arguments. And so we'll be exploring that a little bit further. Recall also that arguments are going to be working with premises, right? Premises are going to be these little building blocks that we are stacking up in support of a conclusion, right? Premises are statements that provide information about the world that are organized in such a way that support or um, lend credence to a given conclusion, right? So arguments are not just random, haphazard arrangements of sentences, but rather they have a kind of rational structure, a rational form. And the form builds from premises which give us that necessary information to believe a given conclusion. All right. So those are sort of the key ingredients in the cookbook of what makes an argument. Now, to move forward a little bit into section 1D of the book, we are going to differentiate two different large areas of investigation that logicians are in the habit of differentiating. Okay, the first is what is called truth value analysis. Truth value analysis is an inquiry into whether or not the premises given are in fact accurate, whether or not they are true statements, right? If I return to the statement, the cat is on the mat, and I ask you to do a truth value analysis of that statement, I am asking you whether or not that statement is accurate. Does it actually represent the real world in an accurate or correct way? So if we look at an example, just a simple sentence like this, it is raining. If I ask you to do a truth value analysis of that sentence, you have to think about whether or not that sentence in this given context is true. Now, this is a little confusing perhaps because you might be in a different location than me. But if I just say it is raining in your location, the task becomes a little bit easier, right? You just look outside the window, and if it is raining, the truth value of that sentence is true. It is correct. Okay, so, on the one hand, truth value analysis might seem like a very simple and intuitive thing to do, but really it's going to raise some pretty vexing questions about whether or not the truth value of statements is necessary in order to buy in to a given conclusion or not. Okay, so we'll talk further about truth value. Now, I want you to be careful in this course in not collapsing truth value on the one hand with what we are going to call logical analysis. Logical analysis is a very different way of exploring the structure of arguments. Rather than thinking about whether or not premises are true, that is, whether or not a given premise is accurate or not, logical analysis is more concerned with merely the structure of the argument in question. Logical analysis determines the strength with which the premises supports the conclusion. And often in logical analysis, we put aside entirely the question of whether or not those premises are true or false. We think only instead about whether or not there seems to be a rational organization of premises with respect to a given conclusion. Okay, so to generalize greatly, more often than not, we are going to be in this class more interested in logical analysis rather than truth value analysis. More often than not, we are interested in formal structure and the kind of rational coherence of arguments. Whether or not statements are true or false will be much less interesting to us. Okay, so let's just look at this. This will take a little time to sort of understand. But if I give you a few premises here in support of a conclusion, premise A, it's just our initial premise, it is raining. And then I add another additional premise to it, premise B, when it rains, games are usually canceled. Okay, and then I give you a conclusion, therefore the game is probably canceled. Okay, so if we were to do a truth value analysis of this argument, we would have to explore and investigate the truth value of premise A, is it really raining? And then we would have to do an investigation concretely, empirically, of the truth value of premise B, when it rains, games are usually canceled. So I don't know how we would do that. Maybe we could just do a Google search, right? Or we could, look up in some kind of statistical manual of the league, right? How often are games, canceled when it's raining? Is that in fact supported by the numbers, right? So we would have to think about, how to do the truth value analysis. And then if we determined that those things were true, we could probably conclude that the conclusion is true as well. Therefore, the game is probably canceled. Okay, so that would be a truth value analysis of that rather straightforward argument. But to think instead about a logical analysis, we would have to put aside the question of whether or not any of those premises are really true and think rather instead about whether or not that conclusion is meaningfully flowing from the premises in question. So don't worry about whether or not premise A and B are true, but think rather instead about whether or not premise A and B are arranged in such a way that we can naturally accept the conclusion. The game is probably canceled. And probably our common sense will tell us that logical analysis shows that this is a relatively good argument, right? It seems to have a kind of rationale to it. We have enough reasoning to believe the game is probably canceled. All right. So that would be a logical analysis of this argument. Now I want to make a distinction that's very important for us between two large branches or genres of argumentation. And this is explored in detail in section E of chapter 1. And the distinction is between what logicians call deductive arguments on the one hand and inductive arguments on the other. So to begin, a deductive argument is going to use very different kinds of inferences than inductive arguments. Remember that technical term from last time. In inference is the leap of reason that is made between the premises and the conclusion. It is the bridge that connects up the premises and the conclusion. When we are dealing with deduction, the conclusion is said to follow with necessity from the premises. And what that means is that if we accept the premises in question within a given argument, it is impossible for that conclusion to be false. All right, so deduction is a very ironclad style of argumentation. It is a style of argumentation in which the inference forces us to accept a specific conclusion if we grant certain premises. Okay. Now, another way to language this, the way that Berdych languages this, is to say that assuming premises are true, it is impossible for the conclusion to be false. This is really the textbook definition of deduction. So deduction does not leave any room for doubt. Its arguments are very black and white. Its arguments are very certain. And for that reason, we're going to be more interested in deduction in general throughout the class, because it will allow us to explore the formal structure of arguments with a lot more certainty than in the case of induction. Okay, so deduction makes arguments in which, given that premises are true, or if we grant that the premise is true for the sake of the argument, the conclusion cannot be false. Another component of deduction, which is perhaps a little hard to understand at first, but I think will become clearer as we start working with examples, is that it does not rely on your experience of the world. In other words, a valid deductive argument does not require you to have any past experience with the content, with the subject matter of the argument. In other words, you can come to a kind of structural analysis about whether or not that inference, whether or not that conclusion is being offered up with necessity on the basis of the content and the arrangement of the premises. So we don't need to do truth value analysis in order to determine whether or not a deductive argument is believable. All right, so I know that's an abstract idea because in ordinary life, we're used to thinking about arguments as relying only on experience, right? If we're given good reasons for believing that exercise leads to weight loss, well, surely that relies on some past experience in which that is true. But as we look further into the history of logic, we will see that there are all kinds of ways of evaluating the strength of an argument without any kind of past experience of the subject matter at hand. Okay. Now, to contrast deduction with induction, with inductive arguments, it should be noted that in the case of induction, let me just move myself here, conclusions follow from premises with a high degree of probability, right? So notice the contrast. With deduction, it is impossible for a conclusion to be false if we grant the truth of certain premises. That's not so in induction. Induction holds that it is very likely for a conclusion to be true, given the truth of premises, but it's not absolutely guaranteed. All right, so it's a lower threshold of necessity than deduction. It's a little bit looser of a form of argumentation than deduction. So assuming premises are true, it is improbable, not impossible, but improbable for conclusions to be false. All right, so inductions are much less ironclad, much less guaranteed of the truth of conclusions than deduction. And often, most of our arguments in everyday life are inductive, in fact. They are appealing to the likelihood of something occurring, they are appealing to the probability of something occurring, but they're not giving guarantees. Induction, unlike deduction, does rely on our experience of the world. Induction um, requires some kind of past familiarity with the information contained in the premises. It requires some understanding and experience of the subject matter at hand. A lot of historical arguments are inductive. You know, if you read a book about I don't know, slave rebellions, you'll find that a historian is usually pointing to past slave rebellions in order to make an argument about the likelihood of another one occurring. So, you know, those arguments are not ironclad, they're not guaranteed, um, but they're referring to probabilities, to the likelihood of certain events occurring, right? So, induction is a much kind of more ambiguous, more open ended form of argumentation. And for that reason, um, we're not really going to be spending quite as much time on the structure of induction as we are on deduction. Okay, so let's look at an example. If I give you a sentence like this, most college freshmen have part time jobs. Andrew is a college freshman, thus, Andrew has a part time job. Okay, so go back to our method of identifying the parts of arguments that we discussed in the last video, which parts are the premises and which parts are the conclusion. We have a very good indicator word with thus. Thus is a very good indication of a conclusion. And so I think it's a fair bet to say that the conclusion of this argument is Andrew has a part-time job. And then we have these other clauses. Most college freshmen have part-time jobs. I think that really counts as a premise. Andrew is a college freshman. I think that counts as a premise. And so just to repeat, Andrew has a part-time job would be the conclusion. So just ask yourself and, write down on a piece of paper whether or not this argument is an example of a deductive argument or an inductive argument. If you said inductive, you're right. The reason that this is inductive is because we have this kind of word that allows for a little bit of wiggle room. Most. Most is a giveaway of induction, or indicates induction. It seems to suggest that, lots and lots of college freshmen have part-time jobs, and Andrew is a college freshman. But it's different than saying all college freshmen have part-time jobs. If this were to say all college freshmen have part-time jobs, then that conclusion would be much more ironclad. It would be much more definite and much more certain, and would count, therefore, as a deductive argument. But here, that wiggle word, most, means that the conclusion is not following with necessity from the premises, but rather it is appealing to the likelihood of Andrew having a part-time job. So if we were to revise the answer, all college freshmen have part-time jobs. Andrew is a college freshman, thus Andrew has a part-time job. This revised version would count as an example of deduction, because all college freshmen would mean that Andrew, by definition, belongs to the class of things college freshmen having part-time jobs with necessity. And so there would be no wiggle room. It wouldn't be an appeal to likelihood. It would be a conclusion following with necessity from the premises. All right? So that's an example of the kind of thing we are talking about here. Here's another example. All dogs ruin the furniture. My sister just bought a new dog. It follows necessarily that my sister's furniture will soon be ruined. Okay, again, try to identify the parts of argument, which sentences are premises and which sentence is the conclusion. And think about the structure. Notice that this is a very forceful argument, right? The language is kind of tipping off that this is deduction, right? It is saying that it follows with necessity that my sister's furniture will soon be ruined if we grant the truth of premise one, all dogs ruin the furniture, and we grant the truth of um, premise two, my sister just bought a new dog. Given that premise one is true and premise two is true, it follows with necessity that the conclusion is true. My sister's furniture will soon be ruined. So this is an example of a deductive argument. So indicator words like necessarily, with necessity, those are good tip-offs that your argument is probably deductive. But beyond indicator words, I want you to think about the real meaning of the argument. Is the meaning offering up the conclusion with a kind of definiteness to it, in which case it's probably deductive, or is it leaving things a little open-ended? It's appealing to likelihood, but not with certainty, in which case it is probably inductive. All right. So this is kind of a habit that we're going to have to pick up when identifying different types of argument. Here's another example. Dogs often ruin the furniture. My sister just bought a new dog. It follows that my sister's furniture is probably in danger of being ruined. Okay, so again, identify the parts of argument. What are the premises? And what is the conclusion? It seems to be that the first sentence is a premise. Dogs often ruin the furniture. I think we could count the second sentence as the second premise. My sister just bought a new dog. And then it seems like we have a kind of lengthy conclusion, which reads, it follows that my sister's furniture is probably in danger of being ruined. Notice that it follows is a very good indicator of the part of argument that is the conclusion. So ask yourself, is this deductive or inductive? Is this an argument in which it is impossible for the conclusion to be false if we grant that the premises are true? Or is this an argument where it's very likely that the conclusion is true, but not guaranteed, that there is a way for it to be false? If you said inductive, you're right. If the premises are true, the conclusion is probably true, but not absolutely certain it's true. There is reason to believe it could be false, but it's appealing to the likelihood of the truth value of that conclusion being true. And the giveaway words here are often. Dogs often ruin the furniture, but not always, right? If it said always, that would be a different kind of sense to it. And then probably. Probabilistic language is a very good indication that the type of argument you are dealing with is inductive, right? Induction deals with experience, it deals with likelihood, the probability of outcomes. And so those are a pretty good tip-off that the argument in question is inductive, not deductive. All right, just some more examples. By the way, this occurs on pages 26 through 27 of your textbook. So if you want to refer back to the text and work on these examples at greater length, you are invited to do so. If we have an argument like this, whoops. Let me just shrink myself here. Okay. Most fruit have seeds. I'm eating an orange. All oranges are fruit, so I'm eating something with seeds. Okay, here's an argument. Seems to be sort of about an ordinary, mundane thing. First, identify the parts of the argument. Which parts are premises? Which part is the conclusion? And then think about whether or not this is an example of a deductive or an inductive argument. Think about this and write down the answer for yourself. If you said inductive, congrats, you are correct. To say most fruit have seeds is different than saying all fruit have seeds, right? And this means that there's a pretty good chance that that conclusion is true because, um, all oranges are fruit, and this person is eating something with seeds. That something with seeds, um, you know, seems to fall into that class within the first premise. But it's not a guaranteed conclusion, right? Could be a fruit without seeds, in theory. Okay. Now, if we were to revise that, and the first premise were to be all fruit have seeds, then this would be deductive. So sometimes it's just a very slight change in language that could mean all the difference between an inductive and a deductive argument. So here's a revised kind of example. Every orange has seeds. I'm eating an orange, so I'm eating something with seeds. So write down, after identifying the parts of the argument, whether or not this is deductive or inductive. And this is deductive, right? The sentence, every orange has seeds, means that there is no room, if we grant the truth of that premise, for that conclusion to be false. I'm eating an orange. If we grant that that is true, it follows with necessity, with logical necessity, that I am eating something with seeds. So, I want you to kind of start to get in the habit of picking up what the interconnection is here between conclusions and premises. How is it rational for a given conclusion to emerge from given premises, right? What is the logical flow, the inferential flow of the argument in question? And notice that with instances of deduction, it's kind of a closed system, as it were. There's nothing sort of outside of the argument, right? The premises are feeding us into the truth of that conclusion with certainty, right? And so for that reason, deduction is going to be much more useful for us. Here's another example. All fires need oxygen. There is no oxygen in that room, so there is no fire in that room. Okay, again, identify the parts of argument. What are the premises and what is the conclusion? And try to indicate whether or not this is a deductive argument or an inductive argument. If you said deductive, you are right. The language of all fires need oxygen indicates that there's a kind of definition, there's a kind of certainty to that premise. There is no oxygen in that room. So here's our conclusion, very good indicator of the conclusion. There is no fire in that room. So if we accept premise 1 as true, all fires need oxygen, and then we accept premise 2 as true, there is no oxygen in that room, it is impossible for that conclusion to be false. There has to be no fire in that room. That is a deductive, ironclad argument that actually doesn't really rely on our knowledge of fires or oxygen or chemistry or anything. It's really just working with the definitions of the terms in question. And that's really what we're after, is an argumentative inferential pattern that allows us to just look at kind of the relationship between the premises and the conclusion without thinking so much about the content of the argument. Okay, here's the last example. No car battery that has at least one defective cell can be repaired. Your car battery has at least one defective cell, so it cannot be repaired. Again, identify the parts of the argument, what are the premises, and what is the conclusion, and then indicate whether or not this is an example of a deductive or an inductive argument. If you said deductive, you are correct. Notice that first premise is a very exclusive premise. It is saying no car battery that has at least one defective cell can be repaired. If it said some car batteries that have one defective cells can be repaired, we would be in a different style of argumentation and an inductive style. But here, that exclusive, definite claim about no car battery having one defective cell should tip you off into recognizing this as a deductive argument. And so it is impossible for that premise to be false if we accept that those premises are true. Okay, so this is just a way of getting us familiar with differentiating deduction and induction. All right, so I kind of encourage you to have a look at least 3 or 4 more of the examples from the pages of this book, just to acquaint yourself with being able to identify deduction and induction. So just to recap briefly, what does logic study? It studies arguments. What are arguments? Arguments consist of statements and premises in support of a conclusion. Arguments can be differentiated into at least 2 branches, deduction and induction. In the case of deduction, conclusions follow with necessity from premises. In the case of induction, conclusions are not certain but follow with a high degree of probability from premises. And in logic, we differentiate truth value analysis, which is an investigation into whether or not premises are true and accurate, from logical formal analysis, which is a structural analysis of the interconnection between premises that are inferentially related to conclusions. Okay, so that's really where we're at so far. In the next section, we are going to have a look further into how to formalize ordinary language arguments in order to look at their properties in greater detail.